Hi friends, welcome to our lesson. I'm Mrs. Gridney, and today we'll be learning another way to compare fractions. Let's get started. In the last lesson, you learned to compare fractions by making common numerators when the numerators were related and making common denominators when the denominators were related. But what about when the denominators aren't related? Do you think we can still compare fractions by making common denominators? Let's find out. Take a look at these two fractions, 3/4 and 4/5. 3 is not a factor of 4, so the numerators aren't related, and 4 is not a factor of 5, so the denominators aren't related either. So then how might we compare these fractions? Pause the video to talk out your thinking. You may have said that we can compare 3/4 and 4/5 using the benchmark of 1, and you'd be right. 3/4 and 4/5 are both 1 unit away from completing one whole. Fourths are bigger than fifths, so that means 3/4 is farther away from 1 than 4/5 is. That tells us that 3/4 is less than 4/5. Now let's confirm our answer or our comparison by comparing the fractions in another way, by creating like units. We can do that even though the denominators aren't related. Let's see how. Let's draw an area model to represent each of these fractions, 3/4 and 4/5, and try to make the area models about the same size as each other, like this. Now, I tried to make my units as equal as I could, but they don't have to be perfect, and yours don't have to be perfect either. Something important to notice, though, is that I partitioned the area model to show 3/4 using vertical lines, and I partitioned the area model to show 4/5 using horizontal lines. That's important, so make sure that you do yours in the same way. Pause the video now and draw your area models to show 3/4 and 4/5 like mine, and I'll be here waiting when you get back. Welcome back. Now, do we have like units? No, we don't. We have fourths and we have fifths, but we can make like units, like this. We'll partition our fourths into 5 equal parts horizontally, just like we can see in this area model. It's kind of like we're going to overlay this area model on top of this one. Now, how many units are in the whole? 20 units are in the whole, so we made 20ths. And how many 20ths are shaded? 15 20ths are shaded, so 3/4 equals 15 20ths. And I'm also going to write it up here underneath 3/4. Now we need to make 20ths in our other area model since we're making like units. So we'll partition our fifths vertically into 4 equal parts. Just like we can see in our other area model, we had those 4 equal parts to start with. So now, how many 20ths are equal to 4/5? 16 20ths are equal to 4/5. And again, I'll write 16 20ths up here underneath 4/5. Now we've created like units. So how can we compare the fractions? Right, just like 15 apples is less than 16 apples, 15 20ths is less than 16 20ths. So that means 3/4 is less than 4/5. We've confirmed our comparison. Way to go. Let's think a little bit more about what we just did. How would you explain to a friend how we decomposed 3/4 and 4/5 so we could compare them? Pause the video to explain. Maybe you said we made common units so we could compare them. First, we drew an area model to represent each fraction. We partitioned one vertically and one horizontally. Then we partitioned each area model again to create like units. Once we had like units, they were easy to compare. 15/20 is less than 16/20, so 3/4 is less than 4/5. Great job! Now let's also show how we created like units using multiplication. This will probably look familiar to you. We've done this before. We're just creating equivalent fractions. So in the first area model, we started with 3/4. When we decomposed our fourths into 5 equal parts, we got 5 times as many units in the whole and 5 times as many selected units. That gave us 15/20. In the second area model, we started with 4/5. When we decomposed our fifths into 4 equal parts, we got 4 times as many units in the whole and 4 times as many selected units. And that gave us 16/20. Now, how is what we multiplied, the numerator and the denominator of one fraction by, related to the denominator of the other fraction? We multiplied the numerator and the denominator of one fraction by the denominator of the other fraction. So for 3/4, we multiplied the numerator and the denominator by 5, which is the denominator in 4/5. And for 4/5, we multiplied the numerator and the denominator by 4, which is the denominator in 3/4. Way to go. Now, how is this process of creating like units or common denominators when the denominators are not related similar to and different from creating common denominators when the denominators are related? Pause the video to talk out your thinking. Well, when the denominators are related, since one denominator is already a factor of the other one, we just have to rename one of the fractions with the denominator of the other fraction. Then we have common denominators or like units. But when the denominators are not related, to create common denominators, we have to rename both fractions with the same denominator. We just have to find a number that both denominators are a factor of. Way to go! Let's try another one. Let's compare 5/3 and 7/4. Now, both of these fractions are greater than 1. So to make it easier to compare them, we can pull out 1. Let's draw a number bond for each of these fractions where one part is 1 whole and the other part is the fractional part that's left. Write with me. For 5/3, we can decompose that into 3/3, which equals 1 whole. And then what would be the other part of 5/3? Right, 2/3. And for 7/4, we can decompose that into 4/4, which equals 1 whole. And then what would be the other part of 7/4? Right, 3/4. Since the wholes are the same, 3/3 is equal to 4/4, we can just compare the other parts, 2/3 and 3/4. So how can we compare 2/3 and 3/4? Pause the video to talk out your thinking. You may have noticed that both 2/3 and 3/4 are just 1 unit away from 1 whole. Since thirds are bigger than fourths, 2/3 is farther away from 1 whole than 3/4 is. That means that 2/3 is less than 3/4. That tells us that 5/3 is less than 7/4. Let's confirm our comparison by creating like units. So first we need to look at the denominators and think, are these denominators related? No, they're not related. So that means we'll have to rename both fractions with the same denominator. Pause the video and draw an area model to represent 2/3 and another one to represent 3/4. In the first area model, partition it into thirds using vertical lines, and partition the second area model into fourths using horizontal lines. Try to make your units as equal as you can, but remember, they don't have to be perfect. I'll be here when you get back. Welcome back. Here are my area models showing 2/3 and 3/4. Notice I made thirds using vertical lines and I made fourths using horizontal lines. Now we already know that we don't have like units, so let's create like units. What will we decompose our thirds into, and how do you know? We'll decompose our thirds into 4 equal parts because that's the unit in our other fraction. Let's do it. What fraction can we see now is equivalent to 2/3? 2/3 equals 8/12. Okay, now what will we decompose our fourths into, and how do you know? We'll decompose our fourths into 3 equal parts because that's the unit in our other fraction. Let's do it. Now what fraction can we see is equivalent to 3/4? 3/4 equals 9/12. Now pause the video and rename each fraction as a number of 12ths using multiplication. You can check your work with mine when you get back. Welcome back. Compare your work to mine and make any changes if you need to. Did you notice that again, we multiplied the numerator and the denominator of one fraction by the denominator of the other fraction? And now that we have like units, we have 12ths, 8/12, and 9/12. The fractions are easy to compare. 8/12 is less than 9/12, so that tells us 2/3 is less than 3/4, which tells us that 5/3 is less than 7/4. We were right. Let's try one more. Let's compare 3/5 and 8/12. How can we compare them? Pause the video to think about it and talk out your thinking. You may have been thinking that these two fractions wouldn't be very easy to compare using benchmark fractions, and they don't have related numerators or related denominators. So we can make like units or common denominators. Right now we have fifths and we have 12ths. If we tried to draw area models like we did before, that would be a lot of little boxes to draw. So how can we find common denominators without drawing an area model? That's right. We could use multiplication like we did before. So pause the video here and create common denominators for 3/5 and 8/12 using multiplication. We'll talk about it when you get back. Welcome back. Compare your work to mine and make any changes if you need to. So with multiplication, we found that 3/5 was equal to 36/60 and 8/12 is equal to 40/60. 36/60 is less than 40/60, so 3/5 is less than 8/12. Excellent work today, friends. You all did so well today. I think you're ready for the problem set. The must-do problems